Hello?
No, you are fine.
Okay.
At least I'm fine.
Okay, so Kaka, I'm making you the presenter.
Yes, Sunil.
Did you get the request? Okay, you are the presenter now.
Yes, can you guys see my screen?
Yes.
All right. So guys, now we have learned about different types of blockchain platforms and private, public, and all. So as you mentioned in last sentence that Bitcoin and Ethereum are the two most popular and widely used blockchain platforms in the world right now. So that's because, and in terms of Ethereum, which has more popularity between developers, because Ethereum was built on top of Bitcoin, and they basically opened the Ethereum as a platform to the developers. It is not just a currency, but it is a platform where you can develop your own tokens, your own currencies, and your own applications as well. All right. So in my practical today, what I'll be doing is we will make use of Ethereum platform and we'll create our own token on that platform. And let's see, like you might have seen all the currencies trading on the platforms and the exchanges, but trading and exchanging is a different part. I mean, that needs an approval and all these things on the exchanges. But based on the facilities given by this platform, Ethereum, we can create our own tokens and we can trade it privately or maybe publicly as well. I mean, if we create our own site and we say that we are launching a new coin and we have an ICO and all everything, so you can start your own business. You can start distributing your tokens using simple and open platform that is Ethereum. All right, so I think I had given you the installation list previously. So in that you had this the browser extension called as MetaMask. So I have also installed the same, and I'll start the practical on my own machine. So just have a look at it. I mean, I've written all the steps that I'll be doing in next few minutes. So all these 30 steps are there. So I'll be performing them one by one, and we'll also explain you what particular step is and how exactly it affects the whole token creation. All right. So first of all, you need to have uh, MetaMask installed on your machine. So I have installed it in a browser. So whenever you install MetaMask, MetaMask is just a thin client for your network. So what it actually does is it's basically a small kind of a wallet, I would say, which manages your account. So whenever you install MetaMask, make sure that you are connected to this network, that is Ropstein test network. This is actually the main Ethereum network where, I mean, to work on this network, you will need a real ethers, and to get the real ethers, you need to spend some money to get real ethers to work on this network. So we'll be working on this test network right now. There are a couple of other test networks as well, like Coven and EBS, but this one is most popular and most mature as of now. So we'll continue with this.
Kaka, I have a question here.
Yeah, tell me.
I was installing this MetaMask for my browser. I was getting this privacy notice, which is when you log into MetaMask, your current account is visible every new site you visit.
Sorry, I did not get your question.
When
when you install it first time, it will ask you to, I mean, it will create a set of keywords which are very specific and unique for your own account, and those will be used to recover your account in future when if you uninstall the extension or something like that happens to your account.
So my only concern is
Mhm.
says that your current account is visible to every new site you visit.
Okay.
So does that mean that whichever
Mhm.
website I'm visiting,
Yeah.
people would be able to see that, or how does it
No,
work?
no, your private key is not shared, but your address is anyway public on the network. So I'll tell you how you can browse the actual network and see your account on the network itself. So for example, suppose okay, so there is a link here called as view account on Etherscan. So Etherscan is the the test network right now. So I mean the etherscan.io is main network, but etherscan.io is the test network that we are working on. So this is my unique address here on this network, which is a test network, and this address, uh, you can distribute this address to the whole public. No worries about that. Your account is always safe because you're not revealing your private key, and this address is anywhere required whenever you need some money from your friend or someone who is sending to you. So you anyway have to send this address to him and say that just deposit some money, some ethers on this account. So revealing this account address is fine. That's not an issue.
Okay, so what you
Okay.
are saying is that there's a public address, which is this address, and then
Yeah,
there will be a private or key address, which
exactly.
will not be shared with anyone.
Exactly. Yeah. The private key is very safe. It is not shared with anyone. Anyway, I can show you how to view the private key as well, but that is not recommended because revealing private key is not a good practice in blockchain. Okay, fine. So let's begin. If you have done with your questions.
I don't have any question.
Okay. All right. So once you install this extension and come to this account will be auto-generated for you. If you don't have an account, if you install the extension in a fresh way, this account will be created. Your unique address will be created automatically, and you will see that you will have a zero balance in your account. So how to get the ethers in my account? Okay, since I'm on the test network, there is a way to buy free ethers. So if you just click on the buy button here and go to Robstream test faucet. So what this test network has provided to us is, oh sorry, it is currently down. Yeah, it is there. All right. So on this test network, you can request a free ether from the faucet. So for example, suppose when I click this button, the transaction would be populated automatically here, and a free ether would be credited into my account. So I had pressed this button for around 10 times before the actual session began. So that's why I have this balance here. But yeah, this works, and sometimes since this is a public network, sometimes it takes some time. But after some time, you will see some ethers are populating automatically in your account, and your balance will go high here. So I have this balance right now, but this is a test network since. And uh, guys, can you mute all of you because I'm hearing some in between a noise.
Now we cannot hear you. So if Sunil is muting everyone, then
Hey, sorry, I was also muted. Can you hear me now? Hello.
Yes, we can hear you.
yes, we
Okay.
can.
Okay, fine. Once I add some ethers here and I have some balance with me, so after that I can create my own tokens and I can then go on with the my own token. All right. So I have added this previously, so just ignore it. Let's add a fresh token now.
Tata, one quick thing.
Yeah.
So, can you this thing process.metamask.io? This is the
Uh-huh.
one test environment where you went and created the account and it gave you some test coin.
Exactly. I mean, when you install the MetaMask, this account will be created to you for you automatically. And when you click a buy button, you will be redirected to this faucet. And this has some free ethers for on the test network, so you can get them easily. No issues about it. Just you have to click this button, and you will see some ethers automatically populating in your account.
Okay.
Okay. So this is not a real ether, so that's why it is very easy. But just make sure, I mean, just assume that you're on a test network and there is nothing real here. Okay. So before that, what we have to do is, yesterday I had shared one contract with you guys. That was this file token erc20.sol. So this is a Solidity token contract. So in that contract, you can see it has some inheritance already implemented here. So this is my base, and this is my token ERC20, and this is my actual contract that I'll be deploying right now. I mean, this is my last in the inheritance chain. So this has all the functionalities. I'll come to this code once we'll be done with deploying it and creating a coin. All right. So now you have installed MetaMask, you have your account, you have Ethers. So these steps are done. So let's jump on to remix.ethereum.org. So
So
remix dot
one
yeah,
more question. Sorry, Shaka. How do I know if it is not going to the actual one and it is going to the test one? This
exactly.
MetaMask, because I just created this and then it asked me to go to my Coinbase account and other things.
Exactly, yeah. So on the MetaMask, we have a big drop down on the top. So whichever network you're currently connected to will show all the balances and everything from that account.
Oh, so you are connected with that test network. Okay.
Yeah. So I'm connected with the Robstream test network. Okay. So now we have MetaMask in place. So Remix is online basically ID. Again, this is created by Ethereum team, and it's a very good it's a very good piece of work that they have done for the developers, so that you don't need the whole setup on your local. You can simply compile the Solidity files online. Okay, so once you have gone to remix.ethereum.org, so this will present you a sample Solidity program here. So this is for just sake of development purpose, but you can simply select all and delete. Now what you have to do is you copy everything from this file that I had given to you. Just paste it here. Okay. Before that, just see the version that we had created this code on. So we had created this code on 0416. So now go to settings and see what is the current version, that is 0423. Okay. So there is a drop down for selecting the versions. So I need to select the exact same version that I had created on. So 0416. Let's come down. Here it is. So you will see that for 0416 there are many entries here. So these are the nightly bids. What happens is if you see the dates on these releases, they are like almost every day a new release comes up. Okay, and once they are freezing on some release number, I mean once they have some stable release, they display with this way without a nightly tag on it. So this is my stable version 0416. I selected. Okay. Now let's come to the compile tab, and you will see that once I paste in my code here, this tab has already picked up my token name. So this token name is present. You can see here it is. So it will list all the contracts present on your file, but I want to deploy my last contract, which is a complete one, that is my advanced token. So just select this one here, and then simply say, I mean, all the warnings and everything will be automatically coming up here. So right now it is showing all my contracts in green state. So that means because they have, they don't have any compilation errors on them, but there are some warnings. So these warnings are fine. I mean, they are fine to ignore. and this is because it suggests some changes in your code based on the the latest additions and improvements in the language. But right now it is fine. So if you make any changes directly in the ID here, just hit right start compile again and it will show the results here. Okay, now let's come to the run tab. In the run tab, you will see that my environment is now Robstring, which is Web3 environment, and it is connected to Robstring test network. And so you'll wonder how these settings have come here directly, because if you notice this address, the account is exactly the same which my MetaMask is having. So you can always validate this account number with this that is showing up here. So this would be same because this ID is made in such a way that it automatically picks up from the MetaMask account. And it will show up here. If you have some different account, some another account, you can always create a new one here and add it here. But by default, it will catch up from the MetaMask if it is installed and show it here. Okay, so we have now compiled our Solidity contract. We have made settings and we are now ready to deploy. So in the deploy section, just expand this one, and this section particularly is a very important one to deploy your token or your coin, I would say. So just see that from where these three parameters are coming from. So these three parameters are coming from my constructor, that is this. And these are, there is one integer parameter called as initial supply. Then there are two string parameters. One is token name and another one is a token symbol. So I'll supply the values for them. But before that, just check that how many digits that we have kept for the denominations. Okay, so so the decimal points that I've given is hard-coded in my contract, that is 8 digits. You can always make it this also as a parameter. You can remove it from here and put it in a constructor, and you can supply it from here. But right now I have made it in the contract itself, so that is 8. Okay, so we'll create 100 million coins. Okay, 8 zeros, 1 and 8 zeros. Then you have to pass the token name. So this is a string, so you have to enclose in the double quotes or single quote here. So I'll say that my coin should be named as MCAL coin. Then this is my token symbol. For example, you have BTC, you have ATH. All these are the symbols for the currencies on the network. So I'll create some new one for me. Say MCX. Okay. So just be careful about these values because you cannot change afterwards. After you deploy it and your contract goes on network. So that is a very tedious job to change all these things again. Okay. So now these values are in place. Just make sure that here again you have the exact same contract that you want to deploy. So in my case, it is my advanced token, so that is fine. Okay, just I'll make sure if I have put the zeros correct. Okay, yeah, I'm fine. Then simply press the transact button here. What will happen is it will contact MetaMask, and to put your transaction or your execution on the network, you need some ethers to pay for. I mean, in this case, now you see my balance has increased because I had pressed that button there 4 times. So it has now gone to 14. Okay. So on this window, you can see that I have a gas limit here. You can change this, but I'll tell you, why not to do that right now, because it's not a real money and it won't cause you any, cost to your pocket. So finally, what the fee that network will be charging to you is that 0.001786 ethers, which is like 1.226 USD. That is fine. But again, this is since not a real money, I'm fine. I'll be just simply submitting my transaction. So now your transaction has pushed to the network and you have got a unique transaction address. You can simply open it and see what it is saying, that your transaction is pending confirmation. That what that means is someone is now going to mine your transaction and validate it and confirm it on the network. So just keep refreshing this page. Your transaction will be validated and confirmed in some time. Sometimes it takes a few seconds, like uh, maximum around 40 seconds, but it depends on the network and the state of the test network currently. So just notice that what is now pushed on the network, our source code is not pushed on the network, but the compiled part, the compiled version of my contract, all this source code is compiled, and the bytecode of the source of this contract is now pushed to the network. You can see what actually the bytecode is. This is like a computer language, but just it is displayed here to make sure that it is compiled, and this is my bytecode right now. Okay, so my status says that it is now success, and you can see I have got a new unique contract address for my contract. Okay, so just open this. This will be a dedicated page for your contract now. So in your contract, you can see I have got a unique address here. Okay, there are some another things which are not yet populated. That's because there is a step to which is called as validating or verifying your contract. So right now, this you will be seeing that this is on Robstream network and it has a public link. Okay. So now to verify or to make sure that you are the owner of this contract, you have to go here. Okay. So now this bytecode is now converted again to source code, and you can see here. Okay. Fine. So before activating this contract, what I have to do is I have to verify this. Okay. So it says that your contract source code is verified. All right. And these are the bytecodes and all these things. If you remember in the yesterday section, there was one thing I had called you about for the event logs. So event logs will be coming up here once my contracting runs on the network, once the transactions are done on my contract. All right. So now my contract is ready, and it is now. It says that who is actually the creator of this contract. So again, this is my address, which was shown in the MetaMask window there. Okay. So if I click, it will take you to my account again. And you can see how my contract was actually processed on the network. So this was the transaction, this was the block ID, and this was the the sender of this transaction or the initiator. And in the transaction, you can again see how it was done. Okay, so I'm going to contract again here. So this is a warning given by the verifier that there is some bug in my code because of the Solidity version, which is not the latest right now. So that's fine. That is not an issue. So you have a contract address now. That's the important thing, and it is verified. So next step is just go to your MetaMask wallet here and say add token. In the add token, what you have to do is simply supply the contract address. So it automatically detects the token symbol and the decimals that were configured for this address. So simply say add and see. I have now this 100 million MCX coin in my account. Okay, so anytime when you want to see what is the contract, you can go here and you can see the total supply is this 100 million MCX coins. Okay, and then again you can see like to whom I have distributed this new token to. I mean, who are the token holders on the current network. So you can see on the network currently there is only one person who is having quantity of 100 million, which is like almost 100%, and that is me again because I am the creator. I have just created this coin, and this is my symbol. This is my coin name, MCAL coin, and so you're ready to go now. I mean, your coin is there. You can send this coin to your your people that you know, or someone who is asking for the coins. You can just take their address and just send them this particular coin. So have you guys understood as of now the steps that I performed here? I mean, I have listed all the steps again in the presentation. There is one step which was not, which we didn't face because I have compiled this contract twice. So there is one step here for the verification, but to do that also, I have also given the steps. So we'll be seeing in the presentation. So any questions, guys, as of now?
Yeah, actually, I have one question. I created this MetaMask account, and then I went to their testing, and I was trying to buy the coin. It doesn't show me, so it said the add token to buy the coin, right?
No, add token is not for the, the buy button is for adding the ethers.
Ether, right? So it doesn't give me anything.
Yeah,
if I click on the add token.
Even if in the beginning you notice that I was getting the coin, I mean the ethers, because there was some network issue at that time. So and at that time my balance was 9 dot something, but right now you can see it is 14.992. So it takes some time to get the free ethers in your account, and post that you can have them.
Okay, just matter of time where it will be added to my account.
Exactly. Correct. So so right now you have added your custom coin here, which is present in your wallet and ready for the transfers. Okay, for the transfers, I mean, before going to the transfers, what I would like to show you that, I mean, what is actually the whole network is. I mean, what is there on the home page, because I'm just seeing the other pages. Okay, so you can see how this network is working on. These are all the blocks that are coming up. You can see all the blocks that are on the network. Okay, and see like what actually this transaction is for. I mean, you can simply go to that particular block and see what is happening in that, what is happening in each and every transaction, and I mean all the details of this uh, network, they are open, and the same is there for the live network also. So that's what I had mentioned yesterday, that on the network you can see what is happening, what is the current transaction going on, who is mining it. But the only thing is that you will see just the addresses. I mean, from this address you cannot guess, or you will never come to know that who is actually owning this address, because this is just a simple string and there is no other information to track it down, or who is the person behind this address. That's the catch, and that's how this network is like open, but again transparent, and still it is uh, a network which is trusted by everyone because it is managed by everyone. That's how it is.
Kaka,
Yeah.
so I have one question. So, if suppose again I get stuck always to that Andhra Pradesh government example. So if I want to implement a blockchain for like my land record transaction, so using the example which you have created, the smart contract we created was for royalty, right? So in that
Exactly.
I will change my business logic to actually do the lease transfer or do some land transaction, and then
Exactly. Yeah.
I can publish this on the this thing. I mean, when I deploy my source code, then I can
Yeah.
say we are live on the blockchain, and this like using our custom business logic for land transaction. And
Exactly.
after that, like, how can I add permission and permissionless concept in this thing?
That is not here because this is as Sunil also mentioned, this is a public network. This is not a private where you have
Okay.
permissions and access rights and all these things. So that's the catch. I mean, this is open network. I mean, once your transaction is pushed, it might be picked up by any miner in the network, and anyone can see what you're actually doing. Okay.
Okay.
So that's why you need the private setups on your own network, and that those should be again permissioned and authorization layers added on that, and you can use them for your own purposes. That's how it is. So on this network, what we are actually transferring and executing is the currency coin. Okay. So in your case, you can change your business logic here, and instead
Mhm.
of just saying and transferring the coins, you can write down the land record data, like the name of the person who is owning it, the area, the
Mhm.
location, all these fields you can create, and you can create your own blockchain for that purpose.
Okay.
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 All
And
right.
I was trying to buy the like the example using MetaMask, and I'm getting a
Hmm.
gateway timed out error from then I'm
Yeah,
trying.
it will give you. Even I got that. Let's check in my case what happens. So even I'm getting user is greedy because I tried it many times and I got 14 ethers in my account right now. So it happens. Just wait for some time.
No
If
problem. No
no
problem.
error is given to you, the ether will be automatically added in your account after some time. Okay,
Okay.
So
fine.
you can
So
also
right
donate
now,
the this one ether, because
uh,
it gave me the option when I was buying it
mhm,
and I was requesting for one ether from the faucet.
yeah,
It was also asking for, do you want to donate it?
yeah. I mean, there are ways. There are many faucets like this which are made for MetaMask and other thin clients. And since this is a test network, it is fine to donate and also receive ethers. That doesn't matter.
And in the real world, are we going to donate it also? I mean, will
In
there
the
be?
real world also, you can donate it.
Hello? Hello?
And stay connect to MetaMask. Fine. All right. So what I'm saying right now is this is my address. You can again see this is the same one. I have 14.992 ethers in my. This is Robstin ethers in my account. And just make sure that you're on the test network, that is Robstin network here. So Robstin has two URLs. That is, one is the infura.io and another one is myetherapi.com. So myetherapi.com is the one for Ether Robstream. So I have selected that, and yeah, I have to connect again to MetaMask. Yeah, and I have my account here. So right now you can see I'm just saying like these many ethers, and my token balances is one this ECN. ECN was my previous currency that I had created, but I am not saying my new currency right here, which is MCX. So to do that, just go to add custom tokens, then again go to your contract, copy the contract address. I mean the same steps that I had done for this thing, MetaMask wallet. So here it doesn't give you the symbol and decimals by default. You have to enter it manually and just save it. And you see that I have 100 million MCX right now here. Okay. So then, so I have my MCX here to how to send it now to someone else on the network. So to send your new coin or your new uh, currency to someone who is there on the network, again it should be on the test network. So you should be knowing his address. Okay. So first of all, I'll go to Send Ether and Tokens tab, and then again to MetaMask and connect MetaMask. So fine, I connected again here. And so in the send section, you can see what it is asking me for. It is asking me for the two address that you want to send the tokens to, and then the amount. In the amount, you can see I have got corruption ETH, which is like given to me free. Then this was my previous currency, and my new currency is also present here, which is MCX. Fine. So I got one address which was my previous account, so which I have stored here. So I copied this address. This is the address of one of my previous accounts on the test network. So make sure that it is an account address and not the contract and other addresses. So what I'll do is I'll send around 100 MCX coins to this guy. Okay. Then it would again simply ask you for gas limit. Gas limit is fine. I'm not worried about. Okay. And say generate transaction. So what it does is it has created a raw transaction and then the signed transaction. Again, this is like just from and to address and the amount. Just that's it. I mean, no big thing here. But this has to be put up on the block again because you're transacting something. Okay, so just say send transaction. So this will present me a dialog box saying that you're sending 100 MCX coins from this address to this address. This is my to address from address. Okay, all the details, I'm fine with it. Okay, just make the transaction. Again, to push a transaction on the network, you have to pay some ethers. So this is the same gas limit that you see in here, and this will come up here and it will cost me this many ethers. I'm fine, and just say submit. Fine. So now my transaction is, it will show here that it is pushed on the network and it has gone some, I mean it has come up with some transaction number which I can check. Notice. Yeah, that's fine. Okay, so what it says that this is my transaction. This was the transaction hash, and the status is succeed. I mean, my ethers have now transferred. Good. So now let's go to my address again. Okay, so in fine. So my transaction is completed, and now you can see my token balance is reduced to this. I mean that is just 100 minus of the 100 million. Okay, and if you want to check whether the money has been or the new coin has been actually delivered and credited to the recipient, fine, I can also check that because the network is open. I can always go to uh, any address and see the balance and everything. Okay, fine. So this is the person to whom I had sent 100 MCX coins. So in the token balances, just come here and you can see yeah, it is still not reflecting here, but because it will take some time to actually update his wallet and uh, you know reflect in the account, but it is deducted from the my sender's account, that is this. You see, this is my account and I got my MCX updated here. Similarly, it will be updated in the recipient's account soon. So my account is updated. I can always check what was the transaction. So I had done this with this transaction hash. This was my account number. This was an out transaction, and the recipient was this person, and the quantity was 100. And this was the token which was transferred to. Yeah, so now you see 5 tokens in his account, and you will see that he got 100 MCX here. Fine. So any questions, guys, until this?
Unless we do the transaction, no.
Sorry?
Unless we do the transaction
Yeah, exactly. I mean, you should try all this. Exactly. I mean, you should try these things. I'm sure that this session is being recorded. You just watch all the recording and perform the steps on yourself, so you'll get an idea how it works and how this network is actually managed. What are these things? I mean, how to actually check the contract and how actually make the transactions of that particular coin you're creating. So you can always point to your MetaMask account. Even if you close these tabs, no worries about it. You can just simply go to your account, and from that you can see what is my balance right now. And you can again check like what transactions I have done based on this network. I mean, for this MCX coin, what are the transactions I've made? Okay. So again, now if you want to check like what is the distribution of my token on the network? Okay, so this was the initial total supply 100 million. Okay, and now you can see there are 2 persons on the network who are holding this token. One is me, obviously this one with 99 percentage of the coins, and another guy is this guy who has the 100 coins in his account.
Kaka, is there I know in blockchain we don't have this possibility of reversing a transaction, but
Correct.
since this is our own, can we implement it because now everything is under our control?
No, everything is still not in our control because we have submitted the transaction on the network. So blockchain is not in our control again. I mean, you can see who has actually mined my transaction. Okay, so this was my transaction. Okay,
Mm-hmm.
so this had gone to the complete public network. Okay, and someone actually mined it and validated it. So I was not there to validate the transaction. That means it is up to the network who actually validates that, and that's how it is. I mean, you cannot control or revert your transactions
This
just
is
by saying
an yeah, this is an exact replica of the global Ethereum blockchain platform that you have. So in terms of
exactly.
our architecture, you can say this is like a pre-production environment. So it has the same code, same features as the actual
Mm-hmm.
network.
Okay, I see. Okay. So apart from doing the transaction, is there a way to communicate between the addresses where I can at least say that by mistake I have sent you this?
No, because
No,
address is not an identity.
if it is done once, it is done once. You cannot do anything. So I
Exactly.
explained it as
Yeah,
one of the
right, right.
scenarios. For banking, you can do that because you know who is the person holding that account. But here, based on the address, you can never find out who is that person holding that account. So you can never communicate with them that you have done a transaction by mistake and they should return it to you. If it is gone, it is gone. And this has happened where people while copy pasting they've made some error or something, and they have sent huge amount of money to accounts, unknown accounts, and they could not do it anything about it on the real network. So if you follow Reddit or Quora, you will see posts like, I have received say for example 100 coins in my Bitcoin wallet. What should I do about it? I mean, should I keep the money, or it could be bad money from terrorist financing or anything? What should I do about it? Because people get worried, right? You get money, you get USDs in your account tomorrow. Obviously the first reaction would be to be happy. Okay, you've received free money, but you don't know the source of that money and what can happen to you. So people, I mean, try to get rid of it.
Okay, guys. So I'll now go through the source code that I had deployed here. But before that, we just have seen a scenario where I push a transaction on the network, it got validated. All this happened in a very short time. Like that's because this is Ethereum network, and as Sunil has mentioned many times that on the Ethereum network, the transaction time is in seconds, and that's how it is made to perform. So that's why we were able to see all these updates in some short time. Okay. So, but actually, what happened behind the scenes? I mean, that's the main thing that we want to know. And uh, like the block, but how actually block gets validated? How actually what is there in the block actually? I mean, that would be my first question. And uh, like what is hashing and what is actually validating the block? Okay, so for these questions, I have created a small, basically a POC kind of a thing, but not in the actual Solidity, but in JavaScript, because JavaScript is a very famous and popular language which people can understand easily, and uh, it does not require you a compilation and everything, but to create POCs and demonstrate something, uh, it is very easy in JavaScript. Okay, so I'll share this URL with you guys, the repo of this URL. It is in my same account, GitHub/enterprise, and then we have Savji coin in that. Okay, so I'll explain exactly what a blockchain is, and what before that what actually a block is. Okay, so I created this JavaScript, okay, which is basically taking one library called as SFA256. Just for the hashing purpose, I've imported this library. Okay, after that, I'm just declaring. Are you able to see the code, right? I mean, the font size is fine.
Yes.
Okay, fine, fine. So this is my block class. In that, I have a constructor which takes an index, then timestamp, some data, and the previous hash. So remember, yesterday I shown you a cube, which was basically a cube representation of the block, which had data, hash, and the hash of the previous block. So simply a linked list kind of structure. Okay, so to create a block, what I need is index, the block number. I need the hash of the previous block, that is previous hash. Then I need some timestamp on that block, and I need the actual data, which is my business logic, and which is the actual entity that is being executed or transacted on the blockchain. So I'll call it as a data. In data, you can put anything here. I mean, you can put any kind of data. You can put any object, string, whatever you want to do. As per your use case, you can customize this part. Okay, but the other parts are like the backbones of the blockchain. But this part is for you. I mean, this is completely free for you to customize it. I mean, you can pass any data and process any data inside this. Okay. Then I have another property called hash, which is nothing but a hash that I'll be calculating immediately when the object is created using the calculate hash function. So what this hash function is doing is it is simply calling the SK256 standard function, but just notice what I'm actually passing inside that. So inside that, I mean inside the hash function, I'm passing the index number of the current block, then I'm passing the previous hash, then I'm passing the timestamp to the current block, and I'm passing the data which is present in my current block. So this complete thing makes a unique signature for my block. Okay, and after hashing this, there is no way to get this data back. Okay, because since the hashing functions are one way, once this gets hashed, it will be converted into some string which is never, uh, which can never be reversed to the actual data or the actual parameters that I passed. Okay, so that's why this is assigned to this hash function, which is basically creating a hash of the same cube properties and assigning to and storing it in a simple variable or the property. Now I've seen just put this code down. Before that, I'll explain you what blockchain is. So in the blockchain, I'm just creating a property called a chain. Chain is nothing but an array. You can see I've enclosed in square brackets. That means it's an array. And inside that, I'm creating a Genesis block. So what Genesis block is, so in a blockchain, so whenever a blockchain is started, so before, I mean, this is a birth of my blockchain. So there is no previous block here. Okay. So my first transaction would be my first block in my whole blockchain. Okay, so for that, I don't have any previous block, so I don't have a hash of the previous block as usual. So that unique and the first block of the chain is called as Genesis block. So in the Genesis block, what I'm doing is I'm simply creating the block instance with some with 0 as my index. This is my timestamp. This is my simple data, and this is again the previous hash, which I'm just keeping 0 because I don't have a previous block here. This is my first block, this is my root. Okay, so in my blockchain right now, I have an array which has only one block, which is Genesis block to start with. Okay, then I'm creating a function in the blockchain called get latest block. So what get latest block will return to me that in the whole blockchain, just return me the topmost block in the current blockchain. Okay, so that is the last block in the chain. Then I have another function called as add block. Add block takes the new block. But before pushing a block on the chain, what I'm doing is I'm creating the hash of the last block that is on the chain. Okay, so what I'll do is in my new block, my previous hash would be the current last block and hash of this. Okay, so my previous hash is placed, which is the hash of the last or the topmost block right now on the chain, and the hash of the current block, that is new block again, is new block dot calculate hash. So my block will simply come with data and other properties, but no hash. So I'll calculate the hash manually and assign to it, and after that I'll just say this dot chain dot push new block. Okay, so my new block is now pushed on the blockchain. Suppose I want to validate my chain because this is the function that is most important in the blockchain, because to make sure that your data is consistent, it is not tampered, and it is always say, I mean, it is always the real data. For that, you need to validate, I mean, some function to validate the blockchain. So now how to validate the whole blockchain? Okay, so I loop all the blocks in the chain. What I'll do is I'll take the current block that I'm looping and the previous block. After that, I'll take the hash of the current block and check with the current block hash. I'll again calculate the hash of each and every block and see whether the hash which is attached to a block, which was some property, uh, if it is matching right now. If it is not matching, I'll say return false. Your blockchain is broken. It is not valid. Otherwise, just move forward and say previous hash and the current block's hash and the previous block's hash should be matched. I mean, the current block's previous hash property. I mean, the hash that I've attached to a block has to be matching with the hash of the previous block. Okay, that is the linked listing that we have studied. I mean, in C, one of the first programs when we learned C as a language. So this is the same thing that I'm doing here. I'm just validating whether the chain is intact or whether it is broken. If this is complete, I'll say that my chain is valid. Okay, so now let's create some blocks and create a blockchain completely. Okay, so I'll create a blockchain which is an empty and a fresh blockchain, but in the blockchain constructor, remember we had created Genesis block in the constructor itself. So that means when I'm calling this, I have one Genesis block in my blockchain. So if I comment out these lines, okay. So what I have in my blockchain is a chain which has this simple Genesis block in it, and this hash you can see the hash of this current block, and there is no previous hash here because this is Genesis block. I'll go further. I'll add two more blocks to it. And I'll show what is there in my blockchain now. Are you able to see this white text? I think it is not as much as visible, but are you guys able to read it?
Yes, it is visible.
Okay, fine.
Yes.
Okay, so in the blockchain, you can see I have now three blocks. Okay, so if you understand the JSON, you can simply, you know, uh, know this curly braces and what exactly this codes and all. Okay, so this is my first block, which is Genesis. This has some hash. Now, in my second block, you can see my previous hash is same as my as the hash of my previous block. So this should match. It is matching. That is fine. You can see the data in the second block is something else. Okay. You can see data in my last block is something else. That is also fine. That means my data is now changed from amount 4 to amount 8. That is fine. But is my block chain valid? Yeah, it is valid visually at least because I can see the hashes are matching and they are linked and they are fine. All right. So I'll run the validate blockchain function now just to make sure that even computer also says that my blockchain is valid. All right. So it says that is blockchain valid. It says true. That means the chain is intact and it is as per the protocol. Okay, so what I'll do is I'll change some data directly in a block. Okay, I won't be pushing another block here right now. So just to demonstrate what happens when a block gets modified in between and your what happens to the state of your blockchain after that. So I'll simply point to the second block in the chain. So this is my chain. This is my blockchain object. The chain is an array. This is second block in that blockchain, and I'll modify the data of that block to 100. Initially, it was this. It was 0, 1. This was 4. So I'll say now modify it to 100. Okay. and post that. I'll again call this. Okay, let's see now what happens. Okay, so now you see after modification my blockchain became this. I only changed the data, okay, but I did not calculate the hash, and uh, I just kept it as it is and then validated my blockchain. So you will see the result what it is right now. It says it is false because when this blockchain was again validated, again the hash of each and every block was calculated, it was noticed that the hash of this block is not matching to the actual contents of this block. Okay, and that's why it is giving me false here. So what if I go and also recalculate the hash of the that particular block which I had modified. So let's go and try that. Okay. So initially I had just simply changed the data and shown you the result. After that, I'll just go to the same block again and say that recalculate the hash of this particular block that I had modified, and now see what the result comes up. Okay, it still says it is false. Your blockchain is still not a valid blockchain. And why that is, you can see the hash is now changed. Previously it was this 92 something, and right now it comes as F5 something. Okay, so it still says that it is not a valid blockchain because this hash and the previous hash property of the next block is not matching. You can see here. Okay, so this has to be in a linear way that I mean to make these changes is not actually possible on the blockchain. But even if it happens, or even if it is gone in a state where data is getting modified, so you will say that this blockchain is not valid. That means something has been tampered on my blockchain, and it is not in a valid state right now. Okay, guys. So to make it valid again, what I have to do is I have to go all the blocks after this particular block, okay, and recalculate the hash and update the previous hash property till the last block of my chain, and that will be like a huge task on the blockchain if it is like blockchains like today's Ethereum or Bitcoin, which has gone huge in the size. All right, guys. So any questions or doubts for this? I'll share the code as well. You can go the code and see what is actually done here.
Hey, Kaka.
Yeah.
Basically, in this, we are just creating a simple linked list.
Correct. Yeah.
As Sunil also went in past, and also I went through documentation. This blockchain is based on Merkle tree, Bitcoin basically, and coming on the Ethereum, that is Patricia tree, means Merkle tree plus tribe.
Exactly.
They have
Those
so
those are having different like algorithms, but for to just represent a normal plain scenario, I've kept it very simple in
This is,
JavaScript.
yeah, this is not the actual, I mean,
Yes,
any
it's not the actual.
implementation code, but concept, I mean, is same. And like you said, Merkle tree. So Merkle tree is also what Merkle tree basically is. It stores the hash in form of a binary tree. So like Kaka was showing you by modifying the data of one of it and calculating the hash again. In Merkle tree, if you were to do that, so what we do is for the first one, okay, from the top, we have, so we start at the bottom, right? So we have two legs, okay, two hashes basically. the parent to that would be a hash of these two hashes. So similarly, the tree
Yeah.
keeps on growing. If you modify anything in between, you have to go on and modify the hashes of everything above. Okay. Otherwise, immediately at the top, it would be recognized that someone has, tampered with the hash below or data below. Now, for you to be able to correct the entire Merkle tree, you would have to have a lot of processing power, which is basically the Sybil attack that we have talked about a lot of times. So that is not possible. That is how Merkle tree does it. Patricia tree is an extended or an improved version of it, wherein you have not just have parents, you have uncle, SHA uncles, etc. So the concept, however, is same, that you store the hashes, and the hashes act as the
So, Sunil, my question is okay. So, what type of data means exactly we want to put in this block? Because this block is getting mined by the miners, not ourselves.
data is up to you
So,
what you want to put your specific application. I mean, on the Bitcoin blockchain, it would be about the Bitcoin transfer, and the address, etc., would remain almost
Yeah.
what we.
I mean, in the currency blockchains, it is a ledger, I would say, and the for the transactions, it is simply from, to, and the amount. So
Yeah.
these three things are the important part of the data that is comes up on every block when a currency is transacted.
so one question basically. So, as on Ethereum, other than coins, we can do other transactions also. So, if I'm doing some transaction to you, you will have some public key me as well. But what about my details? Where can I put my details? Okay, this is Sunil Kishore Pathak, living at address this one. So this type of information will be where?
You mean to say the application specific data, right? Now there are
Yes.
multiple ways this is implemented. One is, okay, like I am assuming that would be 100% case of the Andhra Pradesh example that you guys keep talking about. So in that case, what happens is the data is not stored actually on the blockchain. Just the transaction information is stored and just the hash is stored. However, data is actually stored in physical files in their office, which would have a hash, or some way to link the physical
Some
file
unique,
and
yeah,
uh, the actual hash on the block. So everyone knows this transaction has taken place and this transaction has not been tampered with, because they can browse the transaction hashes on the network, but the actual physical file would be stored somewhere. Now, in say there's an application where there's no physical file, it is a digital asset. So the digital asset is stored in a database or in a directory or on a hard drive. Okay, but the transaction hashes are stored on the blockchain. So that
yeah. For
depends on
Okay.
the.
example, of this,
Yeah.
for example of the land record case, in case of that use case, what I would say that I would say property ID here, property ID, which would be some unique ID assigned to that particular property. Okay, it must be there in the database of the land record office. And after that, the amount is there. So after that, there would be a from guy who will be having again a unique address. Then again, there will be a to guy who will be again having a unique address. So what this data means is that this particular property is transferred from this person to this person for this amount. Okay. So you can customize this data in any way that is feasible to you. You can give it a property ID, or you can again give some another identifier which identifies your property. But once this is pushed to your blockchain, blockchain makes sure that I mean this does not get tampered, or this record is safe, and it is not you know temporable in any time of the any time of the complete life cycle of the blockchain. I mean, whenever the blockchain is there, this record would not be modified or tampered. That's a guarantee that blockchain gives you.
Okay, you mean to say that database having the detail of all the documentation
A separate
will
one,
be
yeah,
will be related with this document ID which is in our
exactly.
blockchain.
Yeah.
So as an user, what will I get? My public key
User
and what else?
No. See, uh, as a user of a blockchain means if you're a node on the blockchain, you will not see this data. Okay. For this, I mean, demonstration purpose, we are just writing it in a plain text, and we can see the data. But in the actual the blockchain, this would again be encrypted, and you can see some random text here which is not readable to you. I mean, you won't understand what it is, but once it is decrypted by the the keys, that can be actually read at that time, but not the from the user perspective what it is.
Okay, basically on one of the site I was going through, it was saying that if some data is stored in Merkle tree data, then they will give you also the Merkle root. But what about the intermediate hashes which will be used to verify? That will be in the database somewhere or where?
I didn't get your question. Can you repeat it again?
Okay, so assuming one transaction go for the money only, I
Uh-huh.
am giving $100 to Sunil Pandey.
Correct.
So public ID A is sending $100 to public ID B.
Yes.
So for me, I want to verify past transactions. So I can go and I can see in my wallet, okay, these are the amounts which I have transferred to this one.
Correct.
But if that transaction history I don't have,
But
can I search to whom I have sent this money?
so Kaka showed you on the Raption network. When you click on the particular address, you would be able to see all the transactions on that particular address that have happened. Kaka, can you open the?
Okay.
Yeah.
Exactly, yeah.
So
So
just
this
show
is
it.
my
Yeah, just show your address, which would have multiple transactions. So
yeah.
yeah,
So in my
you clicked on his address,
particular
and you can see all the transactions that have ever happened. In this account, you don't have lot many, but whatever has happened will always be available. Now, what it does is it automatically goes on the blockchain, on the testnet blockchain, and whatever transactions have happened on this particular address, it pulls out the information for all of it and lists it here.
Okay.
so you can see when I created the contract, so that is
So
also part
similarly,
of
similarly in
exactly.
the case of land also, your
Yeah,
land would be having an address. I mean, if they've built it that way, or if you want to do it on a person basis, it would be the person's address. Say the land was created as an asset, okay, and it had a address itself. When you click on the address of that particular piece of land,
yeah,
it would give an entire
exactly,
history of what transactions have happened on it.
exactly. Suppose now this is
Got-
my property ID address, okay, which is unique for a real property. So if you hit this slash address and give the property address, you will come to know like what all transactions have happened on this particular address. That's it. I mean, very simple. I mean, you can link to any entity in the real world and just make your application on top of this.
Okay, thanks, Kaka. I don't have any question related to today's session. So if others don't have, then I have some more questions.
Okay.
Yeah,
So
go on.
basically, okay, setup. Please go through setup private. I think so. Okay. So basically, my question is now I understand how to create play around their test environment.
Mhm.
So that's
Mm-hmm.
okay if I want to create my own Ether based on the Ethereum platform and other things.
Mhm.
So what about my app? If I want to create something as like someone has created under government or someone has created for song digital assets,
Uh, So we saw
this type
how
of application is
we saw how we create a smart contract yesterday, right?
yeah smart contract. I understand.
So you create, I mean, your app is also sort of an contract. So you write the
Okay.
logic and you push it on the network, and then it is available for everyone who is connected to that.
Okay, in your question, for if I mean, as I said, in case of property, you can term this address for a property. In case of music, you can term this address to a song. Okay, and if you just enter this address and see like whoever has actually listened to that song, so all the transactions would be displayed here, and you can see the details of the transaction, and based on that you can guess the royalty which is credited to the artist again. So that would be a logic of your contract to do internally all the manipulation and processing of your data.
No, no, Kaka, I mean to say, assuming I have a song
Mm-hmm.
and I want whoever listens this give me some
Yeah,
royalty.
correct.
So that is one part basically. So
Yeah.
coming on the smart contract,
Mm.
I will write a smart contract. I will give some unique ID. That I mean database ID which we have shown. So in one database I will put my ID plus that digital song.
Yeah.
And on the smart contract I am putting this ID and writing all the smart contract. Okay, this is the royalty which should be transmitted to that person.
Mm-hmm.
And now I have pushed this code on this Ethereum net.
Yeah.
So if someone is listening, they are listening from my database, not from the Ethereum
Yeah,
node.
you have to, basically for that kind of integrations, right? So Ethereum has a full set of APIs to get the transaction details from the actual blockchain. Okay, so so in your application, you will be able to fetch the data. We will show that in maybe in the next set of sessions.
Yeah, okay.
There are many APIs from Ethereum network and the Ethereum platform. So by just passing the address to that API, you can fetch out all the transactions in your application directly. I mean, this browser is just to display it here, but this data you can anyway get it from the APIs. Ethereum provides those APIs,
Yeah,
and
so
it has a good
correct.
rich
So
set
for
of it.
Bitcoin, if you remember, I had shown you the documentation wherein we had those RPC endpoints, and we saw that you could create it using HTTP methods also, or you could do it in other languages also. Similarly for Ethereum
Yes, yes.
also you have, similarly for Ethereum also you have them available. You build your application in whatever language you are comfortable with to interact with the blockchain. Okay, you have, I mean, similar documentation available for it. You call the API, it will push the relevant data on the blockchain, and that gets registered on the platform. So your application logic can remain in your application. Whatever you need to store on the blockchain, or when you need to integrate or interact with the blockchain, only then you make the specific API calls and register the data or retrieve the data from the blockchain.
Okay, got it. It means some third component I need to write for the interaction between
Correct,
Ethereum node
correct.
or net and database. Okay.
Exactly. APIs are the gateways to interact the actual blockchain. So that's how, I mean, without APIs, blockchain is not useful, I would say. So API is one of the important bridge there to link your applications to the actual blockchains. All right, guys. So there is very less remain for today's session. I just wanted to go through the code, but yeah, I mean, we have some time here, so let's do that. So what we actually deployed is this particular contract, which was my advanced token contract, which is actually inheriting two other contracts in that. So I have split this into this three contracts actually. Uh, so for that, this ERC 20 contract is a special one, which is actually a standard given from the Ethereum guys. So as you know that on Ethereum, most of the use cases is the coin and the currency. So for that particular use case, they have created this contract so that people know what exactly needs to be written in the contract, and what is actually the business logic should be. So what they have done is they have simply made our life easy. They have simply created this contract and kept it open. So as we also have seen in the remix ID, we were supplying these three properties to the contract. So these were actually supplied to this token ERC20 contract, and because it is inherited in the my advanced token. So we compiled this particular, I mean, we deployed this particular contract, but it is actually inheriting the other two ones. So we supplied parameters to this contract here. So this takes these three parameters: initial supply, token name, and token symbol. So initial supply is basically what it does is it takes this value and stores it in a state variable, which is like total supply, which is 256-bit integer. Then the symbol and the name of the contract. Now, here comes the important function, that is transfer. What happens when the transfer of this token is called? Okay, so you can see the body of this function. First of all, it checks like whether, yeah, first of all, let's see the signature of this function, which is address. I explained to you what address is in yesterday's session. So address means the sender's address, which is from, then the recipient's address, and the integer value, the amount of the tokens that you need to send. Then it checks the small condition whether the address is not 00, I mean, whether it's not invalid address or not, and that's fine. We just checked it, and if it is fine, let's go to check if the sender has some enough balance. So balance of is a mapping here, I guess. Yeah, that's a mapping to the address. So balance of from needs to be checked. Then balance of to again needs to be checked, that whether it's not an overflow or something. Then we have previous balances. So what previous balance is doing is it is just taking the balance of previous state of the sender and balance of the previous state of the recipient, and just summing it up, and we can see what it is doing later on. Then it is just subtracting the value from the sender and just adding the value to the recipient. And after that, there is this event log called as transfer, and which is something like from to value. So now, as I there was one topic yesterday which was debugging in contracts. Okay, so now I'll show you how exactly that comes up here. So to debug the contracts, what you can do is you can log the events. So you can see transfer is basically an event here. Transfer is declared as an event, which takes address of from to and the value. Okay, so now you will want to know that where exactly the log is, because there is no server here. Where is my log? Okay, so just go to the transactions that were happening, and here you can see. Okay, this was the transaction under which I transferred the 100 coins. I went to event logs, and I see three values here. So this was my uh, first parameter, this is second, and this is third one. So these are the different representations of the data, but you can always see the logs from your event logs, which are actually present on the network. So I mean that's how it is. Since it is distributed, there is no single server where this particular transaction was executed. It was executed somewhere in the network, but I can see my logs here. So that's how the debugging works. If you want to debug your contract, you can add some event logs here, and compile it again and push it again on network, and just make a transaction again, make some transfer again, and see what the log comes up. Just very similar to what we do in other programming languages like Java, JavaScript, and all these languages. Okay, so other functions are like basic one. This was like transfer from, so which is again calling internally the transfer function, but it is just check the allow. It just checks the allowance whether the value is fine to transfer or not. Again, this is like custom business logic you can build up uh, on your contract based on your data, what you're actually processing, what you're actually transferring based on that, and yeah, so that's how it is. And in the final contract, that was my advanced token, we can see how it is done again. The same things are again checked here just to make sure that, I mean, this is actually re-implementation of the inherent token contract here, just to show that we can override the methods in the derived classes. Yeah, and for this is for the case that suppose you want to change some functionality in the base class and you want to make a different log or something else. So you can simply override the function and re-implement it here. So just go through this source code. You will understand most part of it because we have seen the actual object of this contract on the network and how it actually transferred the amount from one account to one other account. So that's it, guys. I mean, you guys have some homework today. We have covered most of the stuff from the today's module, and like from the types of the different types of the blockchains, and then we saw the practical of creating our own coin on the Ethereum test network. So yeah, so next thing that you guys can do is uh, I mean, you can anytime follow what we did today with MetaMask and Remix ID. But after that, you have a task to do here, that is setting up your own private Ether node on your machine. So there are very good quality articles present on the medium.com. First one is for the Mac OS and Linux guys, and second one is for the Windows specific. So you can go to this articles and follow the steps. And in the next session, we'll be again start with this, how it went with you guys, and we can again see a demonstration of this too in the next session. But before that, go to these articles and let's have them set up on your machine so that we can have a good interactive session where we will be seeing like what are the different errors that you guys face, how to resolve those errors, what was the actual issue, and we will actually validate whether you have done the things rightly or not. And in the similar way, you can validate your your language, your skills that you have learned till now, and based on that, I mean, you will be getting a confidence that you will be able to set up a private blockchain on your own network. So I'll be creating a few things for this again. We'll have some actual network nodes. Maybe I can spin some VMs on my own machine and just show it to you guys. But yeah, before that, just go through this and set it up on your machine so that I can validate whether you guys have done it right or not. Okay, so we have few minutes more. Any more questions, guys?
So, Kaka, can you or Ashok can send this file today itself? Because generally we receive these things after a few days. So we have only 1 or 2 days to complete this exercise.
I will send it to Ashok today itself and ask Ashok to send it to you guys immediately. So I will make that request to Ashok.
Yeah, okay.
Okay, guys. Then thanks for joining, and let's meet next week. By then, hope you go through the session that we did in this week and try to set up the Ethereum on your. I mean, if you have a Linux machine, you do it on your local machine or set it up on Azure or whatever platforms you can create an account on. and then let's continue on next week from there.
One question. If I set up the Ethereum on my machine, it will take that 54 GB, something like that, right?
Yes.
Okay. So it's always good to set up on the some cloud.
Yeah.
Okay. Good. Thanks.
Okay,
And
guys. Thanks.
still, what are we going to cover next week?
It would be multi-chain and setting up multi-chain. So first day would be a bit of theory on multi-chain, why multi-chain is required, and then it would be setting up of multi-chain and few apps of multi-chain.
Okay. Okay. Thanks, Rel.
Yeah. Okay. Thanks, guys.
Yeah.
Have a good day.
Thanks, guys. Bye.
Bye.
Yeah, thanks, guys.